Okay, so today we're going to talk about quadratics and graphing, and you're going to need a calculator, so make sure you get one or use an online version, but you should really get your own calculator. Okay, so we're going to have an example, so let's start with 0 equals x squared plus 2x minus 3. So if you wanted to solve this at first, you would have to factor it. And so since a is equal to 1, right? We have a equals 1, b equals 2, c equals negative 3. Since a is equal to 1, we know that to factor it, we can just do two numbers that add to a times c and multiply to b, right? So negative 3 and 2, it's going to be negative 2 and negative, no it's not, it's going to be positive 3 and negative 1. Okay, so we have positive 3, negative 1, and then we can multiply this out. We could FOIL it to check, right? We could do x squared minus x plus 3x minus 3, x squared plus 2x minus 3. So this is our factor form, and then our solutions are x equals negative 3 and x equals 1, right? So this is the difference. This is a vocab word, factors versus solutions. Right, okay, so let's recap, right? We had this equation, 0 equals x squared plus 2x minus 3. We found our two solutions, x equals negative 3 and x equals 1. So if we were to graph this, on the x-axis, our solutions would be 1 and negative 3, right? So let's put this note here. Solutions to an equation are x-intercepts on a graph. So you sort of want to connect everything. You want to connect the equation and the graph and all the patterns that you see. So let's look at this xy table. We have negative 1, 0, negative 1. Actually, let's do positive 1, 0, negative 1, negative 2, negative 3. We know that negative 3 is 0. We know that positive 1 is 0. So let's look at 0. If we plug in 0, we get 0 plus 0 minus 3. If we plug in negative 1, we get negative 1 squared plus 2 times negative 1 minus 3. So 1 minus 2 is negative 1, minus 3 is negative 4. And then we know that there should be a pattern, right? So if this is 0 and 0, and these two should be negative 3 and negative 3. You could also plug it in to check. Right, so now we have this xy table, 0, negative 3, negative 1, negative 4. And we have our parabola. Right, something else that we could include is our vertex. Negative b over 2a. So negative b would be negative 2 over 2 times 1, which would be negative 2, or negative 1. So this is our vertex, right? So that was from B12.1, and then this factoring would be from like B10, right? Unit 10. Okay, so we're tying this all together. You should know that a quadratic has solutions, which are x-intercepts. You should know that the ABC helps you find those factors, but it also helps you find the vertex, which is the center part. And then if you ever forget all of this, you should still be able to make an XY table, right? If you forgot how to factor, if you forgot how to do the vertex, you can always make an XY table, plug in values for x, find the values of y, and graph it. So it's important to know how they all connect, but you also want to know that in the end, right, this is something that you can always do. Okay, so let's move on. So roots. Roots are where a function equals 0. Another word for roots, which you've seen in our vocab, is x-intercept, solutions, and zeros. So if I say roots of a graph or zeros of a graph, it all means the same thing. It's all these points right here, right? I want to use, I don't know, green, right? These are always our roots, x-intercept, solutions, zeros. Okay, so let's take a look right here. Okay, so our roots are going to be, let's have roots be in red. Okay, so our roots are here and here, here and here, and here, right? So our root is going to be 1 and 5. It's going to be -3 and 1, and it's going to be -4. And then our vertex, remember our vertex is a minimum or maximum. It's also on the axis of symmetry, right? So our vertex is going to be a point, 3, -4, -1, 2, -4, 0. So this one that happens to be both. You can have the 0 and the vertex be the same point, but it's not always that common. So roots you can write as a point too. So you could do like 1, 0, 5, 0. All right, so yeah, let's just be clear, right? Vertex is a point. Axis of symmetry is a line. X equals -b over 2a. Okay, so this vertex, sorry, just to be clear, the vertex is a point, so I'm going to have, and then we just have a y, or like a question mark. Right, but our vertex is, this line is x equals -1. So the vertex is the point, the axis of symmetry is the line. Okay, so we have our roots and our vertex. So what does this mean? It means that if we have the graph of a quadratic, you don't have to factor as long as you can graph it. Because if you can graph it, you just need to find the zeros on the graph, right? You need to find the roots, the zeros, the x-intercepts. Okay, so let's do an example. So we have 0 equals 2x squared minus 3x minus 7. So you could try and factor that. It doesn't come out to nice numbers. So if you use your calculator, you're going to go to y equals, okay, so we have y equals, we put 2x squared minus 3x minus 7, and we click graph. So right now the window is set not so great, it's from something else. So we're going to change the window. A good setting is -10, 10, 1, -10, 10, 1. That's like our generic window, and it can help us see. Okay, so this is a good window because we can see the whole graph. So what you're going to want to do is you're going to do second trace, which is calc. You're going to do 0, and then you're going to go to the left of it, and you're going to go to the right of it. And that gives you one of the zeros, which is -1.27. And then we're going to do the other one. So calc 0, we're going to go to the left, we're going to go to the right, and we can find that second 0, which is 2.6 or 2.77. Okay, so that was really easy, right? These are the two solutions to this equation. So before learning how to solve quadratics by graphing, it would be really, really hard to find this answer, right? If I was like, tell me, 2x squared minus 3x minus 7 equals 0. What does x equal? You'd be like, I don't know, Ms. Lutz. But now you can do it with your graphing calculator. Okay, so I'm going to write down the steps here. So 1, set quadratic to 0 to put in calc y equals 3 set window to see whole parabola for calc, which is second trace, 2, which is 0, and then 5 go left and right to find 0. Right, so you're going to usually do step 2 twice because there's 2 zeros. So just do a little box here, right? These are our steps. And then this is the second trace, second 0, y equals. Okay, so let's do an example, right? So we have -1/2 x squared plus 5x equals -8. Okay, so our first step is going to be setting it equal to 0. Okay, so we're going to move the 8 to the other side. So add 8 to both sides. We have -1/2 x squared plus 5x plus 8 equals 0. Okay, so we set it to 0. We're gonna put it in the calculator. Okay, I know it's really dark. I'll try and put the light on it. It's really hard because I'm just using the flashlight on my phone. It's like very unsteady. Okay, so we have negative. Now let's do the whole number in parentheses. -1/2 x squared plus 5x plus 8. We graph it. Okay. The window is not the best because we can't see the x-intercept over here. So what we're going to do is we're going to expand it a little. We're going to make the x max about 20. And that should show us everything. So we got 1 0. We got the second 0. So it's okay that we can't see the top because we're not looking for it. But if we needed to find the vertex, then we would have to change it, right? So if I wanted to find the vertex, I'd have to change this y max to something taller, maybe like 30. Make this like 4, 2. All right, so now we can see the whole thing. So we're going to do second trace, which is calc. Go down to 0 or just type 0. We're going to go left bound, left, right, whoops, delete. Okay, I think I just typed in 1. No, it didn't find it. Okay. I must have mistyped something. Calc, 0, left bound, right bound. So we have our first answer, which is -1.40. And then our second answer, ooh. 11.4. And let's just check, right? Let's just see if it works. So we have negative, let's actually put in parentheses, -1/2 times x squared. So 11.4 squared plus 5 times 11.4 equals, just about -8 because we rounded it a little. And then let's try the other one. -1/2 -1.4 squared plus 5 times -1.4, just about. So not super exact because we rounded it. If we had put the entire decimal, it would have been more exact, but it's a good way to check. All right, one more. So we have, we're gonna move everything to this side. So we're gonna minus x plus 5 minus x plus 5. We get 2x squared minus x plus 5 equals 0. So we set everything equal to 0. We're going to graph it. 2x squared minus x plus 5. Let's see if this window is good. Okay, so if we look at this window, you can see that it never touches the x-axis, right? So since it never touches the x-axis, there's actually no solution. Right? So if I said 2x squared equals x minus 5, what is x? You'd be like, Miss Letts, that's a trick question. There is no solution. Okay. Just a little bit more. All right. Find the min-max by graphing. Sketch a graph. Okay, so for this one, we're not looking for zeros, but we're looking for the vertex, right? So before in the last lesson, what we would do is we find our x equals negative b over 2a, and our y would be, we just plug in the x that we found. But now we're going to use our calculator. Okay, so the steps are very similar. You want to set it equal to 0. You want to put it in the graph. This time the only difference is you're going to use min or max. So same steps as zeros, but use 3 or 4, which is min or max. Okay, so let's just do it in our, so we can see. Okay, so we have 2x squared plus, see if I get the lighting, plus 3x minus 5. The graph actually works. So we're looking for, we can see there's a minimum. So we're going to do second trace. We're going to do 3, which is minimum. We're going to go a little bit to the left. We're going to go a little bit to the right. And it's going to find the point for us. So we have negative 0.75 and negative 6.125. Right? So easy. Okay, next example is 3 over 4 x squared equals negative 7x plus 2. So our first step is we want to move everything to the other side. So we get 3 over 4 x squared plus 7x minus 2 equals 0. We put it in our calculator. Be careful with the fractions. I would always put it in the parentheses. Yeah? Okay, so parentheses 3 over 4 x squared plus 7x minus 2. We're going to graph it. Okay, that's not good. So we need the y to be lower. So let's do 10. We're going to change the y min to negative 30. We're going to change the y max to like 10. Perfect. So now we can see that minimum. And we're going to do second trace, minimum. Woo, we go all the way to the left. We go all the way to the right. And we get negative 4.6. I'm going to do a line on it. Negative 18.3 with a line over it. And that is our minimum, right? So we could have done this a long way, negative b over 2a. We would have gotten all these ugly fractions, but this way, not so bad. And then finally, this one's already done in 0, so we can just go straight to the calculator. So 0.6 x squared plus 7.5 x plus 8. Let's see how the graph looks. Oh, we don't need to change the settings. Another minimum. No maximums. I'm going to go to the left. We're going to go to the right. And we have negative 6.25, negative 15.4375. You can round this if you want. All right. So finding the maximum by graphing, sketch a graph. Oh, I didn't sketch a graph. Okay, so for this one, we have something like that. And then the other two, you can sketch a graph. Not as important, but if it says it on a test, please sketch the graph. So, yeah, you can use the calculator to help give an idea of the graph. Okay. Cliff diver Kelly stands on a 70-foot cliff. He jumps with an initial velocity of 8 feet per second. So we have this function. We have s of t. We have negative 16t squared plus vt plus 8. S of t is the height of the object. V is the initial velocity. H is the initial height. So in actuality, remember, we need our function to only have the letter that we said it should have, right? So it says the function s only can take t. So this v and this h we need to make sure we fill in. So we have s of t equals negative 16t squared plus our initial velocity, which they gave us, 8t. And then our initial height is going to be, he's standing right here, so this is going to be 70. Right? So this 8 was here. And the 70 was here. Okay, so let's draw a picture. So you should, with word problems, you always want to draw a picture. Okay, so we have a 70-foot cliff. And we can mark this 70 feet. We have Mr. Kelly. He's going to jump with an initial velocity, and then he's going to fall down. Right? So we don't know the object is Mr. Kelly, right? So we don't know where he is. We don't know how long it's going to take him to get to certain points in the air. Let's make this water so that he survives. Okay, so let's just graph it first so we can get an idea of what's going on. Okay, so we have negative 16x squared. So in the calculator, you're just going to always use x's, even though in your formula you have a t, right? Plus 8x plus 70 graph. Okay, so we need it to be higher, which makes sense, right? So our y min can be, like negative 5, and our y max can be 10, was already a little far, so we could do like 6, 1, and then our y min could be like negative 10, our y max, so we know that he starts at 70, so let's make this like 100, and this can be like 10. So let's see what that looks like. Okay, that's pretty good. So even though this is a parabola, we know in the real world he's starting here. So we don't really need this other part of the graph. So let's change that for our window. Our y min can be like negative 1. And then looks like our y max could be even smaller too. Alright, so that's not bad. So let's just put that in here. But this is your personal preference, so this could be different. So we're going to do negative 1, 5, 1. Negative 10, 100, 10. So this SCL, that means scale, is just like how many lines does each thing represent. So if I look here, each line represents 10. And here, each line represents 1. So you can make the scale to your liking. Okay, sorry this lighting is have a bad glare. Okay, so if we look at the graph, right, we can see this is Mr. Kelly, right? And then he jumps, and then he lands in the water right here, right? So the question is asking, when will Mr. Kelly hit the water? So we're going to look for our 0. 0. We're going to be left bound, right bound, and we can see he hits the 0 at about 2.36. So 2.36 seconds. Right? And his maximum height is going to be a little bit after he jumps, right? Because he's going to sort of try and jump up and jump forward. So we're going to do calc, which is second trace, maximum. We're going to go to the left. We're going to go to the right. And it gives us this point. It gives us 2.5 and 71. So 2.5, 71. Okay, so that is our point, but you have to be really careful with what it's asking, right? So it says, what is the maximum height? Or sorry, not 2.5, 0.25. So which one is it? So it's this one, right? It's 71 feet. And then at 0.25 seconds. Right? So be very careful with like what variables you're solving for and try and think logically, right? If you start at 70 feet, well then the 71 probably is your highest point. Remember, with real world examples, we want our answers to contain units. So if you don't have units, I will take half off. You want to be very detailed because I won't know what you mean, right? Like if you said, what is Mr. Kelly's maximum height? If you said 71, it could be anything. It could be like at 71 seconds. It could be 71 meters. So you always want to add your units. So that is the word problem. And so now you can do the rest. You want to be really comfortable with your calculator. You want to, like, remember when you first learned how to use your iPhone and you like couldn't remember all the settings and where everything was, and now it's just you know it. So that's how you want to feel with your calculator.